This is going to be a thermodynamics course, basically at the undergraduate level, and we're going to do it from start to finish. My reason for doing this course and putting it online is really because I TA'd the class a few times, and there were just so many common misunderstandings that I would see students having over and over again, just because things were not explained clearly, and there just weren't a lot of good resources for them, and they would read the textbook and they just still wouldn't understand it. And thermodynamics is actually pretty cool, and when you get it, you can use it to do some pretty cool things. And so, what I hope this course will serve as for you is an introduction to thermodynamics at the undergraduate level, where it really builds upon itself and it builds from really simple ideas. And from those simple ideas, we end up analyzing really complicated things. So, what this is going to cover is going to be a little bit more targeted towards chemical engineering because that's my background. However, it should still be really useful for learning thermodynamics, kind of no matter who you are. So, we're going to basically cover a lot of different things, and the first thing that we'll cover is what is a balance. So, we'll just cover the overall concept of what that means, and then we'll use that to talk about the energy balance and the entropy balance. And then we'll use all of that to talk about cycles. And that's going to be the kind of commonly, you know, reviewed things in thermodynamics like the Carnot cycle, the Rankine cycle, the refrigeration cycle, and so on. And then the course is going to change a little bit because we're going to talk about something that's a little bit different after that. We'll talk about the properties of materials and compounds. And that's where we're going to use multivariable calculus to kind of interrelate all these different thermodynamic variables, like how, pressure changes as a function of volume, if the temperature is held constant, or if the entropy is held constant, and that kind of thing. So there's going to be a lot of multivariable calculus there, but don't worry, we'll review it as we go. And then at that point, we're going to talk more specifically for chemical engineering. We'll talk about single component equilibria, and then we'll talk about mixtures. And as a part of that, that's really multi-component and multi-phase equilibria. In other words, how are components, how are compounds going to distribute among multiple phases? And then lastly, we'll talk about chemical reactions in terms of thermodynamics. So we'll start small and we'll just kind of grow from there, kind of building upon itself every step of the way. I hope you enjoyed the course. I hope it's useful to you. If you have any feedback, feel free to leave it in the comments or email me because I want this to be as useful as possible. And we will do a lot of example problems. I'll try to make it as real world as possible because sometimes thermodynamics can be kind of abstract. And we'll take it one step at a time and go from there. All right, I'll see you in the next video.